G, they find a very bad characteristics. This penicillin can only do a muscle injection because it is acid sensitive. We cannot already take the stomach acid will kill it. Therefore, it developed a second product, penicillin V. What does the penicillin V looks like? Most of the structure are the same. Only here has some difference. CH2, CH, NH. And here are the same. The difference is right here. Now, what is the good thing for penicillin V? Acid resistant. Which means you can orally take. The stomach acid will not destroy it. However, once the penicillin V generates, they used a lot in the hospital. Bacteria is smart. They started to cracking down this. You have this beta-lactam, is that right? I'm going to generate an enzyme called lactamase, or we call it a penicillinase. What does this one mean? I'm going to cracking down here, generate the first antibiotic resistance. So antibiotic resistance started to show up where the penicillin V generated. Okay, people are more smart. I'm going to generate a third generation of penicillin. What is that? Very ironic, methicillin. Now what's the structure? Methicillin, they think they can solve this problem because all these are the same. They put here OCH3. A trimethyl group there. This is the one, in the chemistry standpoint, we call it bulk here. And you can understand it's sick. Okay, the structure is more sick. And they think when you put the methyl there, it's going to be more stable for lactam, and the beta-lactamase will not attack it. Yes, it works very well. However, use too much. Remember this? This comes out. But what the good thing for methicillin? At least temporarily solve the problem. And when they do the methicillin, what happened? This is only penicillin G. Penicillin V is narrow spectrum. Only for gram-positive bacteria. Start from methicillin. They shows kind of broad spectrum. Will be affect gram-positive and negative bacteria. Now, where they attacking gram-negative bacteria is the poring structure in gram-negative cell wall. However, do you think it's enough? If you go back to see the cell wall structure of a gram-negative bacteria, the poring is a very side structure of the cell wall. What is the cell wall major thing for gram-negative bacteria? Lipopolysaccharides. But it's hard to do. Why? It is hydrophobic. We want something hydrophilic. What means hydrophobic is bad? Did you ever heard about some story when people have a muscle structure at the butt? Is it swelling comes out? Because its penetration is very difficult if it's hydrophobic. So technically, at the time, it's difficult to do. Okay, people trying to solve the problem. They generate another one. That's what ampicillin, amoxicillin comes out. Now, ampicillin and amoxicillin, what's the difference? They move this amino group a little bit close. So what is this one going to look like? They move it to here. Then it's the same. Okay, they move this one to here. Is that good? Yes, it's more advanced. First of all, broad spectrum. Second, you can orally take. And less antibiotic resistant by the time. However, right now, because bacteria is more smart than you cannot keep the pace. That's more and more the antibiotic resistance something going to come out. Okay? Antibiotic resistance is another big topic. We could talk about the whole semester. So, just want to let you know, people keep developing. Ampicillin, penicillin, penicillin V, G, methicillin, amoxicillin, it didn't work sometimes. Okay, what we should do? Okay, if this right in the middle doesn't work, what I'm going to do? I'm going to attack some other area. Can I attack here? I can attack in the side chain of the amino acid. This is what vancomycin comes out. Do you still remember Clostridium difficile? Khadif. And I said one of the methods is very ironical. Clostridium difficile is you are using antibiotics for about a week. Too long and killing bacteria too much. You have a water bloody diarrhea. So the first method is what we do. Instead of we use penicillin, we use another antibiotic, is vancomycin. Why? Because if the bacteria has been resistant to the antibiotics, you don't work for here, for the bridge. I'm going to work for the side chain, the transpeptidation of the amino acid side chain. So this guy going to attacking amino acids side chain transpeptide. Yes, that's another way to do it. However, bacteria is smart. They have another enzyme can do, which is transpeptidase. When the bacteria generate transpeptidase, it could be hydrolyzed as vancomycin. Make this more strong. Okay, so it didn't work. Now what we do? If both of them doesn't work, this is cell peptidoglycan. Underneath here is what? Colloid mosaic model, you have these. That's why I want to draw structure. You have these lipopolysaccharides. You have this protein. What's the major function of this transmembrane protein? Is for transport. This is like a wall. Inside, it didn't work. I'm going to bombing. I'm going to do the shooting. I'm going to take the troops go there. It doesn't work. What I do? I don't give you water. I don't give you foods. Can you survive? So what I have to do? This is the nutrients going to go. I'm going to stop the nutrients coming. I don't give you any nutrients. Then how are you going to survive? This is what's the one for basic tracing. We mentioned about the basic tracing. That's an ingredient of A disc. So, what's the function for the basic tracing? Prevent precursor for bacteria cell wall synthesis. That's another way to do it. Okay? But want to tell you one thing. You stop giving the food inside. Inside of here, the people can survive. So basic tracing is only for inhibit bacterial growth. It's not really killing bacteria. So the impacts for basic tracing, we call it static. Not really cidal, not killing bacteria. Okay? This is the whole story. Talk about the development of the penicillin, and it's well explained what happened here on this slide. This slide, I can simply read spending 5 minutes, but when I draw here, you know what happened in the history. When people worked really hard, from penicillin to methicillin to ampicillin, and then we find antibiotics resistance keeps showing up. We find a vancomycin, and then we try to stop it. Then we try to stop the precursor transport. If everything we do, bacteria still survive, what do we have to do? You have to think about the other things. Is inhibit protein synthesis. But it's not really nice, because human being has protein. Therefore, side effects going to come in. Now, how are we going to prevent protein synthesis? Ribosome. Ribosome have 30th, 50th subunits. They're attacking different areas. Okay? Okay, now, some people say, I'm not going to do anything. I'm going to do DNA or RNA. I want to tell you one thing. This is least working. And I've mentioned in my first class, if you are attacking DNA and RNA, don't think it works. Because during the replication, transcription, translation, there's a lot of mutation will generate. So inhibitory nucleic acid synthesis is most of the time is to generate a strains used in the lab. Okay? Sulfur drugs. What sulfur drugs do? We need a PABA. This I will be briefly because we're going to talk about it again. Okay, PABA is a basic precursor for folic acid. Folic acid bacteria must take it from outside of the body. However, if you have a sulfur drug, their structure very similar to PABA, so they will go in through called competitive inhibitory. Bacteria cannot generate PABA, cannot synthesize folic acids. What is this guy? Polymythine. This is ornament. If you have a skin rash, not for syphilis, you can use ornament to do temporary treatments. It's only working on the skin surface because it's leakage of cellular contents. This is cannot do the oral taking. Otherwise, the body will have a cellular contents leaking. Okay, ornaments is a polymythine, is one of the components, only for the skin surfaces. If you really don't understand everything, this is a nice slide. Give you the conclusion for everything. Attacking cell wall, what's the bacteria there? Nuclear synthesis, what's the bacteria there? Cell membrane integrity, metabolic pathway, and the protein synthesis. We will have one question to let you practice in the exam, a review, and what's the characteristics of these antibiotics. Okay? But the bigger story here is this penicillin. This is the key for this component. Okay? Very good.